Okay, so again, just as a quick review, the important thing to remember is when you compute Pearson's correlation coefficient, typically this is done on a sample of data. And as we saw with all of our hypothesis tests, just looking at your statistic is not enough to make a conclusion at the population level. So there is a hypothesis test that tests at the population level. If you could collect all the possible data between these two relationships, would that correlation coefficient equal 0 or not, right? So we can do this hypothesis test using our Excel workbook, and I'll show you a different method later next week. I want to take a little bit of time here to do our last example, but I primarily want to use it as a self-testing opportunity. So what we're going to do is we're going to jump to our Excel workbook W12 day 2. We're going to investigate the relationship between the time spent working at a company and the size of the company. So we're going to jump to the workbook called Time versus Size, Time v Size. And here we have, a little bit of a, here we have some data. We have a simple random sample of employees across the United States where we looked at how many years they worked at a company and we looked at how many employees that company had. So we're trying to figure out, is there a relationship between how long you spend at a company and the size of the company? And you can kind of put your own hypotheses together here. Maybe you think that the bigger the company, the longer you'll spend there, or maybe you think that people are more likely to dedicate themselves to smaller companies where things are more intimate, so then you would have the opposite relationship, right? Smaller companies tend to have people who work there for longer periods of time. All right? So what I would like you to do here is I want you to find your sample size, your correlation coefficient, and your R-squared value. And I want you to plot this as a scatter plot. So pause the video, remember do your scatter plot, find your sample size, find your correlation coefficient, and find your R-squared value. And we'll go over this after you give this a shot. Okay, so remember for your scatter plot, you're just going to select all of your data, and we're going to insert a scatter plot. And right away, we can see that it seems like these dots are pretty closely following a negative sloping line. Now, they're not very, very close, so we maybe will expect a correlation coefficient in maybe the 0.8s or the 0.7s, I guess we'll see. Along the y-axis, I guess I should tell you that the plotting convention here is whatever values to the left, this is going to be along the y-axis, and whatever the variable to the right goes along the y-axis, and the variable to the left goes along the x-axis. So if we wanted to, we could label this chart in a lot more detail. We could call this size of company versus time at company. And inside of the chart design ribbon, we can even add axis labels to make this a little bit more clear. So axis titles we could do horizontal. It'll add an axis title, and we could say time at company, and typically it's a good idea to put your units in parentheses. And we could add another axis title along the vertical axis, and we would put size of company, and number of employees is essentially our measurement unit, so this is a count. And we have this very nice scatter plot now looking at our data. In terms of computing n, remember we're just going to do a count argument, and we want to just select one of our columns. So I'm going to do the Control-Shift down. Our range here is A3 to A68. So we've collected 66 different observations. So each row here corresponds to a person, and each person has a certain amount of time that they've worked at a company and how big their actual company is. For our Pearson correlation coefficient, we use the Pearson command. We select our first array, so this would be A3 to A68 if we're recalling, and B3 to B68. And if you just want to take a quick scroll down and double check that we've selected all the appropriate data, this will be our answer. Oh, so it's actually a stronger correlation than I was thinking. So this is a negative 9.4, Remember, the negative is indicating that we're, typically speaking, the dots are following a negative sloping line. So as you move to the right, your dots should be decreasing. And the strength here is pretty good. So this is pretty close to, in terms of the magnitude, if we cover up the negative sign, it's pretty close to 1. So this is a pretty strong correlation. And remember, we can square our correlation coefficient and get what we call an R-squared value. We're going to have a different interpretation of R-squared next week. But for right now, you want to think of this as just a measure of strength. The closer that the R-squared is to 1, the more the dots are going to follow a line. In fact, if R-squared is equal to 1, you have a perfect, all of your dots along a single line. All right, so I'm just going to write a couple of notes down below here before I give you a little preview of what's coming. So first of all, since R is less than 0, we know we have a negative correlation. And essentially what this means is as time at a company increases, size of company decreases. All right, and this is a general description of how these two variables interact. Now, this doesn't mean that spending more time at a company causes you to lose employees, right? This is not a causal relationship. This is just a correlation. Typically, what it means is that smaller companies, right, companies that have a smaller size, tend to have employees that work there longer, right? And this is a tendency, not an absolute. Okay. The other thing that we can double check here is whether or not this is a significant correlation. Is this a significant negative relationship? And we can use our p-value, correlation p-value workbook to do this. In this case, our correlation coefficient, let's call it negative 9.42. And our sample size, as we just saw, is 66. So we'll put 66 in here. Our p-value here ends up being so small that, never mind, 0.942. Our p-value here ends up being so small that even out to however many digits of precision we have here, it's probably 10 or 11, it's still 0. Now, if we kept adding precision, we would eventually get to some number content, but we're going to have to go pretty far out. Okay, so if you're using this workbook and you end up with just a string of zeros, essentially what that's telling you is that your p-value is exceedingly small. So certainly this is going to be a significant correlation, and we would expect this because this is a very, very strong correlation. So this is a lot of evidence. Forgot my sample size bit here. This is a lot of evidence that our correlation is in fact not 0 because we're getting a pretty strong relationship. So we do have a significant correlation at the population level because our p-value for the correlation hypothesis test was below the significance level. Below our alpha value. Now, the last thing I want to talk about here is just a little bit of a preview moving towards linear regression. So if we assume that we have two variables with a significant and strong correlation, then these variables essentially have a reliable linear relationship. So what I mean by this is that, once again, our dots more or less follow a line. So what we want to ask in the next section and what we're going to answer next week is, well, what is that line? What does it tell us about the relationship? And, what can we do with it? All right, so that's what we're going to explore. And this is all a technique called linear regression. It gives us the line and it gives us some interpretive values and it gives us some predictive power that we're going to see is useful for getting a sense of how this relationship works. So the last thing I want to show you today is just a little preview of some of the stuff we're going to be working with next week. If you click into your chart and you go to chart design up in the ribbon, one of the add chart elements that you can add is something called a trend line. Now I want you to skip over the types and go down to more trend line options. We're going to leave linear toggled. We're going to do automatic trend line. The thing that I want to add is if you scroll all the way to the bottom here, we're going to do display equation on chart and display R squared value. And this becomes a little text box that we can move around. So if you hover over what has just appeared on your plot, you can move this around. Now the nice thing about this, first of all, notice that the R squared value and the R squared value we computed by squaring our correlation coefficient are exactly the same. All right, but this gives you a hint that this R squared, which we're now treating as just like a measure of strength for the correlation, actually has an interpretation in terms of this linear regression, and we're going to talk about what that interpretation is. The second thing it does is actually gives us the formula for the line that's best passing through these points. It gives us a sense of what's the line that these points tend to be following. In other words, it gives us a nice mathematical quantification of the relationship between time at a company and the size of the company. Now, we can actually return these coefficients. Each one of these is going to have a very nice interpretation that will help us describe the relationship. For the slope, right, the term that goes in front of your x command, there's a command in Excel called slope, where if you put in your known y values, so here it is important which one you put in first. You have to start with the y values, which is in your farther to the right, so B3 to B68. And the known x values, this is A3 to A68. If we hit enter here, we're going to get the negative 30.365 that comes from our trend line fit. Okay? So this is the slope of the line that best describes the trend in these points. We can also find that intercept term, that's the addition, the plus 1002.7, we'll call this our intercept, doing the same thing, B3 to B68, A3 to A68. And we can get that same value. Okay, so these are going to help us describe what line these dots tend to be following, right? What's the trend in these dots? Well, if it's a strong, significant correlation, as we have here, then the relationship should be a line. And now we can say what the slope and the intercept for that line is. And what we're going to talk about next week is not only how we get this sort of trend line, how is this defined, how do we choose that line, but we'll also talk about how different parts of that line, like its slope and its intercept, are interpreted, and what are the things that we can do with this trend line once we know it. Okay, good work this week.